Children, once again we are back to GURUDEV coaching classes, and please have a look at our routine. Monday we have physics, Tuesday again we have physics, Wednesday we have mathematics, Thursday also mathematics, Friday we have chemistry, and again on Saturday we have chemistry. Right? Please try. Hello children, once again we are back to our GURUDEV coaching classes, and the topic I am going to start today is electrostatics. Electrostatics means charges at rest. We will be dealing with static electricity, not current electricity. However, in our next chapter children, we will be dealing with current electricity. So please have a look on the whiteboard for static electricity means electrostatics. In this chapter children, we will be discussing today conservation of charge, and our next topic will be quantization of charge. Our next topic will be children Coulomb's law of electrostatic attraction. After this children, we are going to read So clear to everyone what we are going to read today? Conservation of charge, quantization of charge, Coulomb's law of electrostatic attraction, and after that superposition theorem. So children, we are dealing with conservation of charge. In any isolated system, net charge remains conserved. It means it is not possible to create or destroy net charge in any isolated system. Isolated system. Charge can be created or destroyed. Right? So children, we will move to our next topic, that is quantization of charge. What does quantization of charge say? It says in all charged bodies in nature, if charge is represented by Q, it becomes equal to NE, where N belongs to integers and E means charge on clear to everyone? Quantization of charge say in all charged bodies in nature Q equals NE. Q means quantity of charge in any charged body. It becomes equal to charge of one electron multiplied with an integer. Clear to everyone? Now I am going to discuss ESI. It means electrostatic induction. What I am written here? Electrostatic induction, and here I am writing polarization. What is the difference between the two? This is very important. One is electrostatic induction, another is polarization. Presence of charge in a conductor when a charged body is brought near it. This is also the same thing, almost the same thing, but there is small difference. Please have a look. You can easily differentiate between the two things: induction, polarization. Separation of charge in a conductor when a charged body in a conductor, please see there, conductor, when a charged body is brought near it. And what is the polarization? Accumulation of charge in a non-conductor when a charged body is brought near it. Please look, have a look, children. What I have written here? Charge body, separation of charge in a conductor. When a charged body is brought near it, this is known as electrostatic induction. And what the polarization is? We have here non-conductor. And whenever a charged body is brought near it, accumulation of opposite charge is known as polarization. Please cut. So now children, we are going to study Coulomb's law of electrostatic attraction. What Coulomb said? If there are two charged bodies, both are separated by distance r. So children, from our primary knowledge, we know that opposite charges attract each other and the like charges repel each other. Same thing here. You are seeing two charges plus Q1 plus Q2. They are separated by distance R. Again we have two unlike charges plus Q1 minus Q2 separated by distance R. They are repelling each other and they are attracting each other. Here F12 means force on charge Q1 due to charge Q2 and F21 means force on charge Q2 due to charge Q1. Now children, I will teach you what Coulomb stated about that force. Means F12, value of F12 or value of F21. Coulomb has stated something about it. Now I am going to teach you only this. Force is directly proportional with magnitude of charge. Again, it is inversely proportional with square of distance. Coulomb stated that electrostatic force of attraction or repulsion is directly proportional with product of charges and inversely proportional with square of distance between them. So we have for removing the sign of proportionality, we have to give here a constant. So this will become equal to K Q1 multiplied with Q2 divided by R square. Please cut. Coulomb's law. We said that force on 1 due to charge 2 equals force on charge 2 due to 1 equals K Q1 multiplied with Q2 divided by R square, value of charge 1, value of charge 2 and the square of distance between them. And the value of K comes to be K equal to 1 by 4 pi epsilon naught, which equals 9 into 10 to the power 9 Newton meter square per Coulomb square. And you can easily calculate the value of K. What are the unit of K? and the dimensions of K by using the formula F equal to K Q1 Q2 by R square. So F into R square is equal to K into Q1 multiplied with Q2. So K equals F into R square divided by Q1 multiplied with Q2. Now unit of K. Unit of K. Unit of F is Newton multiplied with meter square divided by Coulomb into Coulomb. Right? So we have got Newton meter square per Coulomb square. So the value of K is 1 by 4 pi epsilon naught equals 9 into 10 to the power 9 Newton meter square per Coulomb square. Please. In dielectrics, F equal to K Q1 Q2 by R square. But in dielectrics, children, value of K becomes K equal to 1 by 4 pi epsilon, only epsilon, where epsilon equal to epsilon naught multiplied with permittivity of epsilon equal to epsilon naught into epsilon r. Epsilon naught means permittivity of space, where epsilon r means permittivity of medium. So children, please have a look here. We have just discussed Coulomb's law in scalar form, not in vector form. In our next class, children, we will be dealing with Coulomb's law in vector form. Question number 1 says, if 2-point charge is Q, capital Q, 2-point charge is capital Q, are kept on opposite corner of a square, and two charges Q and Q are kept at other corners, right? Then net force on the charge capital Q is 0. Then ratio of Q is to Q equals to what? Our options are 1, -1, -2 root 2, -1 by root 2. Please have a look here. What our problem says? Our problem say like this. We have one square. 2-point charges capital Q are kept on the opposite corner. Like this, we may keep. And the two charges Q and Q are kept at other corners. Like this, we may have. Since this is a square, all sides will be equal. Then net force on the charge capital Q is 0. Force on this charge capital Q. Please focus here. So children, what you are seeing here, this is one square. we have 4 corners here. On 2 corners, we have capital charge Q, 2 opposite corners. Same time, at other 2 opposite corners, we have a small charge Q, right? Then problem is saying that the net force on the capital charge Q is 0. So, in this problem children, we have to calculate force on this capital charge Q kept at one corner. Let us assume on this capital charge Q, force due to this corner will be F2, force due to this corner will be F1, and force due to this corner will be F3. Force due to this charge will be F3, force due to this charge will be F1, and force due to this charge will be F2. Please cut. So see here solution children. According to problem, F1 plus F2 plus F3 should be equal to 0. Now F1 equal to force on charge is capital Q due to this charge, right? F1 means force on charge is capital Q due to this small charge Q. This is F1. F1 equal to again F2 equal to same distance A, charge force on charge capital Q due to this small q. F2 equals now F3. F3 means force on charge this capital Q due to this capital Q. So F3 becomes F3 equal to K Q into Q divided by what will be the distance? So this is A square and the diagonal length will be root 2A. So this will become clear to everyone? We have calculated F1, we have also calculated F2 and we have calculated F3. But according to our problem, F1 plus F2 plus F3 should be equal to 0. Please cut. F1 equal to KQQ by A square, KQQ by A square, and this is here angle is, our angle is 90 of course. So what will be the sum of F1 and F2? F1 plus F2 should be equal to square root of KQQ by A square Clear to everyone? Now we have just calculated F1 plus F2. This value will be root 2 K QQ by A square. Okay. Now F1 plus F2 plus F3 should be equal to 0. Root 2 K QQ by A square plus, when this will be added to K Q square divided by, means F3 K Q square divided by root 2A whole square, it should be equal to 0. In our next step, children, you can easily simplify it. Again, K will be cancelled, Q will be cancelled. In our last step, children, we have got the result, the ratio of Q is to Q. In our last step, children, we have got the result, the ratio of Q is to Q is minus 2 into. Clear to everyone? Okay? So this is our answer. Please see here, children, our question number 2. Question number 2. 2 point charges Q n minus 3Q are kept at a distance D on x-axis, where we should put a third charge Q so that net force experienced by it is 0. So children, just have a look here. 2 point charges Q and minus 3Q, 2 point charges Q and minus 3Q are kept at a distance D on x-axis, where we should put a third charge 2Q so that net force experienced by it is 0. And here we have the options, 4 options we have, right? See here, children, what the problem says. 2 point charges. Here is 1 point charge, one is Q, another is minus 3Q. Suppose this is x-axis separated by a distance D, where we should put the third charge. Third charge is 2Q. Where we should put a third charge 2Q so that net force experienced by it is 0. Means where you have to put a third charge 2Q. Where means, what question is asking? Question is asking you the distance. Distance at which the third charge should be kept so that the net force experienced by it is 0. Please hold. Please have a look at the solution, children. One charge is Q, another charge is minus 3Q, separated by distance D. According to problem, at what distance, means where we have to place this third charge 2Q. For a time being, let place this charge 2Q here. 2Q. So, this distance will be, let this distance is x. Distance between the charge 2Q and minus 3Q will be d minus x. Force on charge 2Q. Force on 2Q due to Q. It comes out to be F equal to K 2Q into Q divided by x square. Clear? Same time, force on minus 3Q due to, force on charge 2Q due to minus 3Q. We have just calculated force on charge 2Q due to Q, and now force on charge 2Q due to minus 3Q. It will be like this. Divided by clear to everyone? We have calculated the charge on So children, what you have seen today? We have just calculated the value of x, means at what position the third charge to 2q should be placed so that net force over it should be 0. F1 plus F2 should be equal to 0. F1 equal to minus F2. We have calculated like this. Okay. And we have got the result. X should be equal to d plus root 3d by 2. Please be with us, support us, like our channel, comment on our channel. Okay. We will be delivering you the quality service like this. Thank you.